Hello and welcome. Today we're diving into a really sneaky threat. It's something that doesn't just hack AI systems from the outside, it actually corrupts them from within. It's called data poisoning, and honestly, it's one of the biggest challenges facing AI security right now. All right, before we jump in, just a quick heads up. What we're covering here is a high-level summary. The full tutorial from Virtualization Options LLC goes way, way deeper. So if you really want to get into the weeds, be sure to check that out. We rely on AI for so much these days. Financial advice, even medical diagnoses. But just imagine what happens if that AI has been secretly taught to lie, to mislead you at the absolute worst possible moment. That's really the heart of the threat we're going to unpack. And that brings us right to this hidden threat. We're talking about corrupted data. See, this isn't an attack that breaks the AI's code. No, it poisons the very foundation of how it learns, essentially teaching it how to fail on purpose. So, what exactly is data poisoning? Well, you can see the formal definition here, but think of it like this. It's the deliberate act of injecting bad, malicious data into those massive datasets AI models use for training. It's like giving a student a textbook that's just filled with subtle but incredibly dangerous errors. What happens? The student learns all the wrong information, and in the same way, the AI model learns all the wrong behaviors. And believe me, this isn't just some theory. This is happening right now. Just look at this chart showing where these attacks are hitting. Yeah, the tech sector sees the most, but look at financial services and healthcare. A poisoned trading algorithm, that could vaporize millions of dollars in seconds. A corrupted diagnostic AI, well, that could have life or death consequences. The stakes here are just incredibly high. Okay, so how in the world do attackers actually pull this off? Let's crack open their playbook and take a look at where and how these systems are most vulnerable. One of the key things you have to understand is that an AI system is vulnerable at pretty much every single stage of its life. Attackers can poison the huge general datasets used in the beginning, or they can make these really surgical strikes during the fine-tuning stage. They can even mess with how the AI fundamentally understands and represents information. The attack surface is just enormous. Now, the attacks themselves kind of come in two main flavors. First, you've got your non-targeted attacks. Think of these as a blunt instrument. Their goal is just to mess up the AI's overall performance and make it unreliable. But then you have the much more sinister, targeted attacks. These actually install hidden backdoors that an attacker can activate on command with a specific trigger, causing the AI to fail in a very specific and very malicious way. And this quote right here, this gets to the absolute core of the problem. The most dangerous attacks are designed to be invisible. A poison model can pass every standard test you throw at it. It can behave perfectly normally for weeks, months, even years. But that backdoor is still there, just dormant, waiting for that one specific trigger to go off. So, how do you fight a threat you can't even see? Well, this is where a whole new field of cybersecurity is stepping up. AI penetration testing. These folks are the specialized defenders of AI integrity. And it's so important to get this. AI pen testing is a completely different beast from the traditional kind. Traditional testers, they're looking for flaws in code, in networks. AI pen testers, they're hunting for something else entirely. They're looking for flaws in the AI's learned behavior, corruption in its data, and those sneaky hidden backdoor triggers. It's a whole new ballgame. Their toolkit is, as you can imagine, highly specialized. They're doing deep data integrity assessments, using special algorithms to spot weird patterns, and running adversarial tests where they try to craft the exact inputs that might trigger a backdoor. They're constantly monitoring the model's live behavior for anything strange, and even use something called continuous automated red teaming, which is just relentlessly simulating new attacks to stay one step ahead. So you can see how this actually works in the real world. Let's take a look at a case study from MindGuard, who are a real leader in this space. They've built a platform specifically designed to hunt for exactly these kinds of vulnerabilities. And the results, they're pretty impressive. During their validation testing, the platform was able to successfully identify 95% of known poisoning attacks. That's some powerful evidence that, with the right specialized tools, these hidden threats can absolutely be found. But here's the crucial part. The real-world impact. By using this platform, a single financial services company found critical vulnerabilities in their fraud detection AI before it went live. And get this, that discovery helped them avoid potential losses that were estimated at over $50 million. I mean, that just makes the business case for proactive AI security crystal clear, right, doesn't it? So, finding the problems is step one. But what's next? Let's talk about the long-term strategies for building AI that's truly resilient and trustworthy. Okay, once you find a vulnerability, you need a multi-layered defense. It all starts with super rigorous data validation to clean up the training set. Then, you need strict access controls to stop bad data from getting in the first place. And you've got to have continuous monitoring to watch for any strange behavior in the live model. And if a model is compromised, you have to scrap it and completely retrain it on clean data. And this defense has to constantly evolve, because as you can see from this timeline, it's a never-ending cat-and-mouse game. As soon as backdoor attacks first showed up, attackers developed even more advanced techniques. Now you're seeing regulations like the EU AI Act trying to catch up, and attacks from really sophisticated groups like lapsus, which means the pressure is always on for defenders to keep innovating. Ultimately, this all leads us to the most important takeaway, I think. Securing AI isn't just a job for the security team. It absolutely requires deep collaboration between the security experts who have that adversarial mindset, the data scientists who really understand the model's behavior, and the developers who are actually building the systems. It has to be a shared responsibility. So, we'll end with this thought to chew on. As AI becomes more and more woven into every part of our lives, shaping our decisions and our world, the question isn't just about what AI can do, it's about the integrity of its foundation. As AIs build our future, who is it that ensures they're building it on a foundation of truth?